Morning. Today I'm just taking an example of a simple beam. How to draw the reinforcements for for a simple case. So let me consider that there are four number of the bars in the top face and there are four number of the bars in the bottom face. For example, the concept of the reinforced cement concrete was introduced in order to overcome the brittle nature of the concrete. Okay, now I would like to take one small example of the concept of the concrete and reinforced cement concrete. Okay, so in the initial stages, when concrete was introduced, yeah. So let us take an example of a concrete beam. It is a pure concrete beam. So let us subject it to as a loading. The loading can be anything, the point load or the uniformly distributed load or anything. So when a complete concrete member is subjected to loading, obviously due to the force acting on it, the beam will try to bend in the downward direction. The beam will try to bend in the downward direction. Okay, so as the process of bending, the beam will try to develop cracks from its bottom face. That is, in the case of the simply supported beam, tension will be acting at the bottom face, compression will be acting at the top face. So since concrete is very much brittle in nature, the formation of the cracks stops from the bottom face. Okay, so the beam will try to bend in this direction. The beam will try to bend in this direction. So as a result, there will be a formation of cracks from the bottom face. So if you continue to load it further, what happens? This cracks will propagate till the top fiber, and there you can expect the complete failure of the beam structure. Okay, so the brittle nature of the concrete do not have the capacities to carry the greater flexural loads. So as a result of this, in order to improve its loading carrying capacity beyond its flexural capacity, the concept of reinforcement was introduced. So how this reinforcement will play effectively in resisting the propagation of the crack till the top fiber. Okay, so what happens here in this case? So let us consider the same example of the beam bending in this direction. Okay, so without the provision of any steel member, what happens? The crack will completely try to propagate till its top fiber. So in the initial stages, obviously there will be a formation of cracks like this. In the absence of the reinforcement, the cracks will try to propagate completely till the top fiber. So if you provide this steel bar like this, so this is your steel member. It can be anything, FE415, FE500, FE515, as per the codal provision and the requirement for the from the point of your design consideration, you can adopt. So due to the presence of this steel fiber, the cracks will stop propagate till the extreme fiber. So the presence of this steel fiber, it will restrict the propagation of the cracks till the top fiber. Thereby you are making the member more ductile. So in order to make any structural member more ductile, the reinforcement plays very important role, and also to avoid any brittle nature of the failure or the sudden failure of the member, uh, the presence of the steel plays very important role. So if at all, if you can expect any kind of the failure, the first always we will design it as an under reinforced section where the steel member will undergo larger deflections. Thereby physically anybody can notice that the beam is undergoing a deflection. So when it is continued to loading further, first there will be a formation of the cracks due to its further loading. The cracks may widen, and then the steel member also will undergo larger deflection. So this is the concept why the introduction of the steel member into the concrete was taken place. Okay, then so now next we shall consider a small example of drawing of a simply supported beam which consisting of four number of the bars in the tension phase, four number of the bars in the compression phase, and it has two-legged vertical stirrups. Okay, and the stirrups are has having usual spacing, that is a common spacing from start to end. So this example I'm just taking in order to make you understand how the reinforcement will begin. So okay, so here I'm just taking the example of the simply supported beam. So it will have two simple supports at both the ends like this, and there will be tension at the bottom face, there will be compression at the bottom face. So as an example, I'm just considering there are four number of the bars acting in the tension phase, four number of the bars are acting in the compression phase. See, you can also observe a 3D drawing here. You can also observe a 3D drawing. So this is your three-dimensional drawing where you can see all the views here: longitudinal view, cross sectional view, everything. Okay, so as I have told you, there are four number of the bars in tension. Okay, similarly four number of the bars in compression. Okay, so this is just an example for problem, four number of the bars in the compression. Okay, uh, yeah, let's consider. See, in the sketch you can clearly notice here. So assume that this is a simply supported beam. See, you can clearly understand there are four number of the bars here. You can count one, two, three, four. There are four number of the bars in the compression phase, and there are four number of bars in the tension phase. Okay, so and the stirrups also you can notice. The stirrups are normally connecting both the compression reinforcement as well as tension reinforcement. So beam is very much predominant in the shear. So in order to avoid any shear failure, the requirements of the shear reinforcement is very much mandatory in the beam, because flexural, in the case of the flexural member, both longitudinal reinforcement as well as the shear reinforcement plays very important in resisting any flexural stresses and the shear stresses. Okay, see, in any of the given problem, it is very much necessary to draw the in general we do not draw always 3D diagram, so we always go for the 2D representation. So how many number of the bars, how many number of the still legs in case of the shear reinforcement. So for the example what I have considered, this three-dimensional drawing is very much clear to understand. So once you know this simple topic, you can apply the concepts, say, in a similar manner to any kind of the beams with any kind of the reinforcement. Okay, so this is a three-dimensional one. You can see all the concrete which is in gray color. So inside the concrete you can also notice the reinforcing bars. You can also notice the reinforcing bar. Okay, yeah, there, as I have told you, there are four number of the bars in the tension phase and four number of the bars in the compression phase. So this is bar number 1, 2, 3, 4. There are four number of the bars in the compression. As well, you are having four number of the longitudinal bars in the tension phase also. Okay, there are four number of the bars in the tension phase, and it is a two-legged stirrup. See, this is referred as two leg. This is one leg, this is one. Normally it will be wrapped around the longitudinal bars. Okay, this is an example of the two-legged stirrups. So let us come to the two-dimensional view. So you are starting it from one end, and you are taking it around the longitudinal bars in both top and bottom face, and you have to connect it carefully. Okay, yeah, so you have to do, the representation is normally in the two-dimensional. So whatever you observe from this side view, so whatever you are observing this side view, so this is referred as the cross sectional view. See here what you are observing. So here what you are observing, so let us draw the cross section of the beam. So whatever, let us say it as B, and let us say it as D. So there will be a cover. So depending upon the design or the IS 456 provision, cover also has to be considered. Okay, so then the reinforcements in the cross section. See how many longitudinal bars in the, there are four number of the longitudinal bars. So that four number of the bars you have to draw like this. Okay, at the bottom also There are four number of the bars. Okay, then this is representation for the stirrups. Okay, this is representation for the stirrups. Yeah, next longitudinal drawing. How do we draw the longitudinal section? So this is your longitudinal section where you cannot see all the four number of the bars at the top and bottom because it is an elevational view. Because it is an elevational view, there will be one bar behind one. So you cannot see all the four number of the bars in the elevation, whether it is top face or the bottom face. So that is why in the elevation, that is longitudinal section, we will represent the beam in the longer direction. So with the given span or whatever, so imagine that it is having a span of L. Okay, for the given span length, we have to represent properly the reinforcement. So in the top bar also you can notice only one bar. Okay, but practically in three dimensional there will be four number of the bars, and at the bottom also we are representing it only one bar. Okay, next you can see the two-legged stirrups. So you can see the draw the two-legged stirrups like this. You can draw the two-legged stirrups like this. Okay, then after this you can draw the reinforcement details. You can draw the reinforcement details. So it is an example of two-legged vertical stirrups. So whatever the spacing it is given, you can write it down. And similarly, you can also write the four number of the bars. Okay, four number of the bars of central diameter. So if it is 10 mm dia, you can write it as 10 mm. So similarly, bottom also you can represent it as there are four number of the bars with at 10 mm of 10 mm dia or 12 mm depending upon the data.